Here are the goals of chapter 1.4. Students can identify what the numerical relations are, functions, by using graphs, mapping, ordered pairs, and equations, okay? So what's a function? You know, that's the question. Students can understand and use the proper notation and vocabulary of functions. Students can find the value of a function for a particular value of the independent variable. Which one's independent? X or Y? X. You have all the control over X. Put whatever you want in. Okay. Students can find values of the function f of x when is it equal to 0. And students can determine the domain of a function graphically and algebraically. Okay, let's go. Here you go. So this is your note packet. I'll be done in 20 minutes. So if you guys just give me 20, I'll let you work the rest of the hour. Here we go. Look at that first one. Is it a function, yes or no?
Yeah.
Because a function is every x value gets what?
1y.
Exactly 1y. So the 2 went in, and how many came out? Just 1. 3 went in, 4 came out. Okay? Every x that went in got one answer. But, so this is a yes. But what if I would have thrown a 4, -10 at you?
No.
You'd say no because 4 can't get 2 answers. And 4 is getting 5, 4 is getting -10. It doesn't work. That's when you'd say no on the test or quiz. Okay? All right. But ignore that, please. Here we go. Okay. There's a section in your homework that you ran into right here. Is y a function in terms of x? I think it was from like 19 to 30 something. You ran into this and you probably just didn't know what to say or do, but it looked like 24 and 27 like this. So here's my question. See this one right here? Is that a function? Every x value gets exactly one y value. It's either yes or no. Yes?
Yes.
How do you know
It's
this?
a line.
It's a line. Is every line a function?
No.
No. So you can't just say it's a line.
It's not a vertical line.
It's not what?
It's not a vertical line.
What's wrong with a vertical line?
It's like it's just the same as you're getting a ton of y values.
Yeah, a vertical line, 3, 0, 3, 1, 3, 2, 3, 4. So vertical lines are not functions. Okay. But you're kind of right when you say it's a line. It's a function. But here's the way I would tackle these kind of problems. I would just quick solve it for y. Okay, so 2x comes over, becomes what? -2x plus 6. Divide by -1 and get what?
2x minus 6.
2x what?
Minus 6.
-6. Okay, and then if you want to know if that's a function, okay, if you want to know, well then you just try and get a couple points out of it and just see what happens. If you let x be 3, how many answers do you get? 6. 2 times 3 minus 6. 0. You got one answer, didn't you? Okay, if you let x be 6, what's the answer? 6. You got one answer. So you're always getting one answer. So if you're always going to put an x in and get one answer, you'd have to say what here? Yes. Okay, look at that one over there, though. What would you do to x squared plus y squared equals 9?
It's a circle.
You what? Yeah, you would, eventually. Solve it for y. If you solve it for y like I did the previous problem, it'd be 9 minus x squared, right? Equals y squared. How do you solve for y? Okay, now remember back in Algebra 1, 9th grade, take the square root of both sides. You bring in how many values?
2.
What are they?
Negative and positive.
Plus and minus, exactly. So, did I do that right now? Yeah, I did. Okay. So, if you just throw a number in, what if you let x be 2? So, if I let x be 2, 9 minus 2 squared is 4. 9 minus 4 is?
Plus or minus 5.
5. Well, it's actually plus or minus Square root of 5. So how many answers did you get for 2? No, just 2. Positive square root of 5, negative square root of 5. You got 2 answers, and you can't do that to be a function. So here's where you'd say, no, it's not a function. So when do you think it's going to be a no when you're looking at the equations? When you get the plus or minus. If you ever take the square root of both sides, plus or minus. If you take the 4th root of both sides, plus or minus. The 6th root of both sides, plus or minus. So what root? Even roots. Well, the even roots will not be functions, okay? And you'll figure that out if you solve it, okay? How about that one? This one right here. I heard no, I heard yes.
Yeah.
Okay, put something in right here. Put a what? A 2 in? A 1? Okay, we could do 1. Well, I did 2, so 2, put a 2 in. 6 minus 2 squared? 2, square root of 2, isn't it? Do you see a plus or minus out there? Without the plus or minus, this is just a special function. They just call it positive. They just have a positive out here. Then you'd say what? Yeah. Yes. That's a yes. They started you with just positive. Don't in your mind bring in the negative. There's no need to. Yeah.
Would there be any restrictions on that? So let's say
Yeah, there'd be, like if I asked you for the domain, there would be a restriction, but let's not get there yet. That's 2 slides from now. But you're right. All right, next. Graphs. If you see a graph, there's an easy way to know if it's a function. Vertical line test, which means if I draw a vertical line right through any number on the x-axis, 3. How many times did I hit it? Once. So that means 3 gets whatever number this is. I don't know. I'll just call it 2. 3 gets 2? Good. How many times did I hit it? Once. It is a function. Yes. How about this one? No. If this is 6, 6 got what?
3 and negative
2 answers. Yeah, 6, 3. 6 what? Yeah, this one is no. Vertical line test will give it away. Good? Yeah, just a nod. Eyebrows up, eyebrows down is a nod, sort of. Okay, let's go. All right, we did this on Friday. That's why we can kind of cruise. So, given this function right here, f, by the way, f is the name of the function. There it is. X squared minus 3x. Evaluate the function at x. Well, x is your independent variable. I'm choosing what number? 2. Evaluate that function when you plug in an x value of 2. Go. In your notes, just jot it in there. Do it quick. Squared minus 3 times 2. Answer is negative 2. Okay. 4. Take away 6. Negative 2. Right? By the way, when you plug in 2, you get out negative 2. You just found what on the graph? If it's a parabola, you just found a point. Your point is, I put in 2, I got out negative 2. I found a point. That's all you did. Okay? All right, f of. This time it's not a number, it's an algebraic expression. So you're not going to get an answer like 10, 12, 14. You're going to get an algebraic answer, okay? Plug it in for x. Plug it in for x. See what happens. Okay, x plus 2 squared minus 3 times x plus 2. How do you take x plus 2 and square it? Do you FOIL it out? Yeah, because what it means is x plus 2 times
X plus 0.
itself, right? And then this one,
Distributed.
yeah, you could probably run that through right now and get negative 3x minus 6. Okay. Back here, though, be careful. Foiling is, can get a little messy. X squared plus 2x plus 2x plus 4. And then bring down the minus 3x minus 6. Look for your light terms, any light terms. X's all over the place. X squared is different than x's, so these two with this 1. Let's bring down the x squared. X's add up to what? Plus x, plus 1x minus 6. And there's your answer, right there. Oh, I didn't see the 4. Sorry. Good catch. All right, so that is, okay, 6, negative 2. Got it. Good. All right, this one is a little different. This one says, it doesn't say f of any number. It just says take your function and ask yourself, when will your function equal what number? 0. So really, remember this replace y. When will y be what? 0. So up there, you just replace f of x with 0. And the function was what?
X
Was it x squared?
minus 3x.
Minus 3x. Okay, there you go. So what x value is it that makes this equal to 0? Okay. Well, don't tell me the answer. Tell me how to get the answer.
Factor of x.
Factor. You can do the quadratic formula. It's a mess. Don't do it. If you can ever avoid that, do it. Take out what? Yeah, GCF. They share x's. They don't share numbers. So what's left is? Right. And then, of course, you're saying, when will this times this be 0? So that's going to happen. Set them both equal to 0. And you get 3 and 0, right? So what two values for x will make it 0? F of 0, f of what? F of 3. When x is 0 and 3, this is when you get 0 for an answer. Oh, by the way, those zeros, that's what they are, they're called zeros, are also called what? X-intercepts. These are x-intercepts also. So 3, 0, and what? 0, 0. Okay. Any questions? So when they say, when will f of x equal 0? Replace f of x with 0 and then solve it. And most of the time you're looking at factoring. Okay, here's a quick slide on piecewise graphs. Now, piecewise graph is when they give you a function g of x is equal to this function right here, or it's equal to this function right here. But here's your restriction. Only use this function when you plug in numbers less than what? 2. Like 1.9 is less than 2. Plug it in. Okay? Only use this function if you're plugging in what? Yeah, 2 or bigger. 2 or bigger. Okay? So here we go. Find g of 0. What's it equal to? Well, 0 happens to be what? Is it this one or this one? It's top. 0 is less than 2. So don't go into this function. Go into this one. So what is g of 0? 0 take away 4? Negative 4. I understand this. You found a point. What's the point you just found? No. Well, yes, you did. Yeah, you plugged in 0. You got out negative 4. That's what you found. That's all it is. Every time you get an answer, you're just finding points. You put something in, you get something out, that's a point. Good? You guys probably saw all of this. You did your homework Friday night, right? Probably right when you got out of school? Or was it Sunday night at 10:30 last night? I don't know. Okay, here we go. This would be probably the toughest part of the assignment. Find the what? Domain. And by the way, the domain are the what values? X's. Okay? So the domain would be the X's. All right. There was something we called the implied domain. Every time you look at a problem, you always say to yourself, what can I put in for my X's? Anything. You can put anything in. Now that's a group of numbers called the all real numbers. Okay. So the implied domain is this. All real numbers. You just always think everything works. Okay, but there's a problem. When you run into this look, even roots like the square root of a number, the what? Give me another one. What? Fourth root, yep. Sixth root. Okay, that's what they're talking about. When you run into this look, even roots of positive numbers only. That's not true. Even though it says that, it's not true. You can also take an even root of negatives, no. Zero. Yeah, it should have said and. Sorry, it didn't say this, but it should say and what? Zero. Because you can take, what's the square root of zero?
Zero.
Yeah. What's the fourth root of zero? Yeah, so you can do it. Okay. Now, what else? When you see this, when you talk about domain, it excludes x's that make the denominator what? Zero. So like if you say 1 over x is your function, what can't that number be down? Can't be 0. So you'd say all real numbers except what? 0. What if I went like this to you? Now you'd say all real numbers work?
4.
Except 4. Yeah? Yeah? Okay. All right. You see these three? Go get the domain. All right. Concentrate. Are you looking at those two restrictions I talked about, even roots or denominators that happen to be 0? Look at that one. Do you see radicals at all? Nope. So you don't have to worry about number 1. Do you see a fraction where x is on the bottom? No. So the implied domain is what works here. Is that true? Put a 0 in. Can you square a 0?
Yeah.
Okay. Can you square a positive number?
Mm-hmm.
Like 10?
Yeah.
How about negative 10? Can you square that?
Yeah.
Anything. So what's the domain? That was done. Look at the next one. You see a problem?
3 and negative 3.
Well, you got what? Do you have a radical or do you have a fraction with x on the bottom? You got a fraction, guys, and if you have fractions, you can never divide by 0 down here. So you can say to yourself, anything works, all reals work, but that's not true. This number down here can't be what?
3 and negative 3.
Oh, okay, but it can't be 0. Okay, so if it can't be 0, you should be thinking, when is it 0? So that's what I would do. I would quick solve it. And some of you are pretty talented. You can do it in your head. And some of you, you need to show work. So if I look at that, how would you solve that? Factor, okay. So you'd probably go x plus 3 times what? Yep. And you'd say the two answers coming out of this are what? Yeah. And you'd say, okay, so when x is 3, or negative 3, I get 0, and I can't have it be 0. So then you go, all real numbers work, comma. But that's not true. X can equal what, though?
3 or negative.
Yeah, 3 or negative 3. Good? Although I will tell you this, some of you guys don't even have to factor it. Some of you might choose to do this, and if this is you, that's fine. You might choose to do it algebraically. Algebraically, move the 9 over, right? Now what? Square root, and get what? So some of you might not factor it. Some of you might just solve it algebraically. Good. Last one over here. Here's a function. You see the radical, I hope? This is a problem. Because you can't take the square root of what numbers? Can't take the square root of negatives. So what can you take the square root of? Not just positive. And 0. So what you're thinking is if I can take the square root of a positive and 0, I'm kind of thinking, when is this number in here going to be bigger than what?
Greater than or equal to 5.
No.
Greater than or equal to 0.
Yeah, I want to know when is it going to be 0 in here or bigger. I want it to be 0 or bigger. So now solve it.
Well, that says greater than or equal to 5.
Yeah, and there it is. So as long as you plug what in? 5 or bigger, it's going to work. So I would say my domain is all real numbers, comma, as long as you plug in 5 or bigger. Let x be 5 or larger, okay? Does that work? Is 4 bigger than 5? No. Plug it in. Square root of 4 minus 5 is negative 1. Can't take the square of a negative. It doesn't work. That's why I'm trying to tell you 4 doesn't work. But what works? 5 or bigger. Okay? Paul, you okay?
Yeah.
All right, do you lose something? You look like you're looking wrong. Yeah.
What's the rule where you have to switch the sign?
It's coming up.
Okay.
It's coming up, but I'll give it away. Anybody? When do you switch the inequality?
Divide by negative.
Okay, so if you had a negative 3x equals 9, divide by negative 3, you get negative 3 here, switch to sign. Or, there's another one, multiply by negative, or divide by negative. Okay, that's it. And that's coming up in, I think, just a second. Okay, I think this is the last one, isn't it? Yeah? Okay. Here we go. This was on your worksheet last Friday. I didn't make it. So if you ran into this problem in your assignment, I hope you skipped it. All right. Here we go. If f of x, by the way, the function f is 3x minus 5. If f of x equals 3x minus 5, then evaluate that. F of x plus h. Okay? Go. Do it. Just get it on paper before I do. Hopefully you substituted this number, x plus h, into x. So you wrote 3 times x plus h minus 5, and you distributed through and got what? 3x, yep, 3x plus 3h minus 5, right? And is there anything you can do over there? Like terms anywhere? No? Okay, done. That's the answer, right? Okay, hang on now. Here's what's happening, and this is getting you ready, believe it or not, for April. In April, we will be in like chapter whatever, and we use this quotient of functions, and it's used for a reason. I can't tell you why, not yet, but they want you to evaluate that quotient using this function. So take f of x plus h minus f of x, divide the whole thing by what? H. Have you already done this part? Yeah, it's right there. So you could write what? 3x plus 3h minus 5. And then it says to subtract What are we subtracting?
3x minus 5.
Okay, but that's a binomial.
Negative 3x plus 5.
And because it's a binomial, you got to use what? Yeah, you're going to subtract. Well, what are you subtracting? You're subtracting that whole thing, right? So you're going to have to run it through, the negative. Divided by h. All right. So run it through and you end up with what? Negative 3x, positive 5. And in the front you have 3x plus 3h minus 5 over h. What happens on top?
Put stuff together.
Yeah, put it together, but what happens when you put it together?
You cancel.
They disappear, don't they? Okay, it's 3x with a minus 3x. A 5, take away a 5, what's left? 3h over h. Well, you know, when you have multiplication, anything that looks the same can cancel out. It's what? When we get to April, that 3, it means something to you. You just don't know right now. But that's what you'll be doing in April. It's in one of our last chapters. We work with that a lot. Okay? That's about it, isn't it? Or is there another slide?
It says 2x there, so it's 8.
Oh. Okay, I was going to do it with you, but 89, I'd like you to get started. So if you can dig your book out of your bag or whatever, let's go. Oh, there it is, right there. I'll give you about a minute head start, then I'll jump in. This is actually the first problem in your assignment today. This is day 2 now. This second half of this lesson, you're going to be reading stories about functions, and you got to make sense of them. That's why I just want to get you started on these stories. You understand the problem now? You got a big sheet of metal. It's a square piece. But what by what? 24 by 24, good. So this is 24 by 24 by 24 by 24. They cut off the corner So they snip it here, snip it there. How far? How far in do they go? X. So they change the cut. Once they cut that piece off though, this is gone. And every time these are gone, now I could take it and bend the flaps up. I can bend this up, and then create that box, right?
Yeah.
Now, tell me the height of the box right now. Yeah, it's the cut, whatever I cut it. Did I cut it 1 inch, 2 inch, 3 inch? What did I cut? Anyways, whatever I cut, the taller the box gets. But the volume will change as you do that. So then part A says this, looking at the table they created, you tell me the maximum volume. Which one is it? What cut?
4.
Yeah, isn't it 4? If you cut 4 inches, the volume turns into what? 1,024. Okay. All right. There you go. Isn't that your guess? I mean, it's the largest volume. It has to be your guess. It's the only information you have. Okay. Part B says take the table and do what? Plot the points. Graph. Okay. Go. Do that. I'll catch up to you. Any guesses why I'm only concentrating on the positives, not the negatives?
The box can't be negative.
Can't cut negative inches, and you're not going to have negative volume. Your answer's in here. It's in quadrant 1. I was lucky enough to go by ones on the x-axis. What did you do for volume?
Hundreds.
You went by hundreds? Okay.
Started with a break.
You did a break? Well, then if you did a break, then you started with what for your low end? 400. Okay. Hey, you know what? I want to do that. Nobody's ever said that before, so I'm going to do that. Okay. This is what Davidson told me. He said, since the lowest Y value is 400, why don't you do a break? You just start at 400. You can do what Maddie did, because honestly, Maddie, that's what I did last hour. Started at 100. Okay. 4, 5, 6, 7, 8, 9, 10. That's 1,000. 1,100's here. Okay. All right. So quick graph it. You have to help me, guys. I don't know. If you cut 0 inches, what's the volume of your box?
0.
You don't even have a box. 0. If you cut 1 inch, help.
1.
The volume? 480. Yeah, I knew it. 4 something. Okay, 2 inches? 800. 3 inches? 4 inches?
1024.
Okay, and 5?
980.
Okay, it's coming down. 6?
864.
Okay, there it is. Now you don't need to connect them, just graph or plot. Okay, now you can kind of see this looks like the max right here, doesn't it?
Yeah.
Okay, all right, it happened at what? A 4-inch cut. All right, now, part C. Part C says write the formula, write the function for volume in terms of X, the cut. So the volume of the box. Write the formula. Where were they getting all these numbers? They were getting these numbers from the formula. You generate the formula. It is a box. What's the volume of a box? Okay, length times width times height. Well, what was length and width? 24 minus 2x. What's this one? Okay. 24 minus 2x times 24 minus 2x
Times X.
times the height. What's the height? X, right? Times X. There it is. Isn't that your function?
Yeah.
Okay, you could clean it up a little bit. You could say what? 24 minus 2x squared. Maybe put the x out here just because that's where the GCF usually goes. Okay? Now here comes the hardest part. Take your function and give me the domain. What's the domain? That would be the x's that I can actually use and get answers for. All real numbers, that's what we always think. It's all real numbers, but that's not true. Because it's a story problem. In story problems, things get
Except for
set.
negatives.
What?
They can't be negative.
They can't be negative. So that's, negatives are out. You can't cut negative into it. And your volume is never negative, right?
Can't be zero.
If you cut 0 inches, do you have a box?
No.
So it can't be negatives, can't be 0, so it can be positives, right? Now,
Right.
can I go forever?
No.
Why not?
You run out of.
Because it comes back cut.
It's only 24 inches, right? So if I start cutting x, eventually I run into a problem because I have no more cuts. I can't cut 2 equal pieces.
X is greater than x, greater than 0 and less than
12, less than 12,
How'd you get 12?
because it's half on each side of the box.
Okay, so she says 24. If I move in 10, I still have a little left. 11, I still have a little left. And then you hit 12, what happens?
You have 4 squares.
Well, you just cut out 4 equal squares. There's nothing left. There's no box. But here's the deal. Mathematically, hey guys, please listen to this. Mathematically, the answer is this. It has to be a positive number, correct? So here's what I would do. I would say this times this must be positive. What's positive? Whoops, I didn't mean to put what? I didn't want to put equals. Okay, it's got to be greater than 0. So here's the deal. Do this exactly the way you've been doing these kind of problems the last 2 weeks. This is a factor times a factor. It has to be greater than 0. Set them, not equal to 0, but set it greater than 0. So when will x be greater than 0? Well, that is your answer. All x's must be greater than 0, but, hang on, when will this factor be greater than 0? Okay, set it greater than 0 and solve it. Move the 24 over, right? Divide by what? Negative 2. Now what? The sign switches and becomes what? All x's must be less than what? 12. So here's the deal. What's the domain? All x's must be greater than 0, but also all x's must be what? Less than 12. There's a better way to say this. Don't say it separately, say it all in one. Write it as a compound inequality. All x's must be greater than 0, but less than 12. And of course, we're talking about what? Real numbers. So could my cut be 11.3?
Yes.
Sure. 10.1? Sure. I mean, anything between here and here in the group of real numbers. Okay? That's it. If you want me to come and help you on that quiz because you just flubbed up, I can come.
I think I quit.
Yeah.
Can I also?
Yeah. You got enough time? 6 minutes? Yeah, you can.
They're all story problems.
It's just gonna help. How do you know that?
Like, it means so little to me. Not just what it should be. I gotta figure that out. Hey guys, if I walk by you and you have 1, 3, Cameron, do you have one? Did you have to hand this in? If you have 1-3 ready to go, last week I got them, but not everybody gave it to me last week. Anyways, quiz okay?
Your idea, please.
Early. I got sweet. Here's my charger. Yes.
Go get it.
Yes. Okay, quiz is okay, guys?
Yeah.
Early.
I'm tired.
Quiz okay? Quiz okay? What's that? Oh, 1-3?
Whose phone just got snipped?
Mine, bro.
Morgan.
Oh, 1-3, okay. What about you?
You're really good.
Is it okay?
Here, I'll save your battery, Morgan.
I'm gonna just plug it in instead.
I just saved your battery.
No, just do This is 1-3? Awesome. And you guys did look at your calendar, you see a quiz coming, don't you?
Yeah.
Wednesday. First quiz of the year, the real quiz. We did, they had it on Friday, and now today someone
So I'll just mostly.
Well,
This is me.
Oh, yeah.
It's all about read a story. Right?
I'll leave.
I was texting my cousin to get ready. Literally, I just grabbed it.
I don't, it's always.
We had his definition for what's this. It was really short. Structure was organ.
Dude, what's up with you trying to fix everything?
Because
You're different. Structure or organ or body function is a function. So it's the structure of organ from
Just grabbed it.
Okay,
I just found
it says.
it wasn't even on. The screen was locked. It was just behind my head. And it was just fresh off the charger. I didn't even know it was
So you need to. So this tackle. From where? So I guess it's so. But it's not what you're going to
5 minutes. Beat.
So you know that the child gets involved in but if you plug in the surge, so how far it comes from where we originally the child stands.
Then like there's a problem.
Oh, is that it?
I was mowing. I was in the riding. Don't tell me that's not. Oh, that's why I put a little loop
You done? Good?
I said,
Yeah. You need to chill. You should have come to volleyball. I know.
I'm just doing hers right now.
John, you're one to be two shoes just comes to class.
You use the, this must be green.
Coats all red.
That's it.
You scared me there for a second. I thought you were so long.
I don't know. You still heard me.
I could do it all the way up to
Fine.
and I
Got here?
You're gonna say I'm wrong out there. Turns out I only did it last year.
The one
They had to this sort of trying to kick around the bus by them. I know.
Oh, I got to that. But I thought I was like 103.
So the people that I just think I got to the school. Why not?
Oh, 51 was.
We have to lunch the one at 5 and 6. Yeah, so we're gonna make it to like 7. Like I would rather be practicing.
Miss Nelson, something for a friend of mine.
Go ask who?
Miss Nelson.
Oh, yeah.
Okay.
It's like,
I'm not sure how to do half the crap.